Dear students, in previous videos, we have learned what is a Navy-based classifier. Now, Navy-based classifier is capable of finding a probability of events with the independent features. Okay. Now, today we are going to learn BaseNet. The other names for BaseNet is Bayesian Belief Network or Bayesian network. And this is totally based on your Navy-based classifier or Bayes theorem. Okay. Now, as I told you in previous video, that probability of H given D means what? The probability of a hypothesis given evidence. Now, what is the goal of BaseNet? We want to find out best hypothesis from some space H of hypothesis given set of the evidences. Now, the set of evidence will what a data set. That is the observed data. Okay. Now, that we will name it as a D. Now, what we want to find out the best probable hypothesis when a data is available to you, when a set of evidence is available to you. Okay. Uh, Here you can consider a example as a coin problem. Okay. Now, what are the terms in probability? P of H, that the probability of hypothesis is what? Prior probability. Now, P of D, that is the probability of your sample data. That is the probability of evidence when you don't have any knowledge about hypothesis. Now, probability of D by H means what? The probability of observing data, observing the evidence when hypothesis H is the target. And P of H by D is what are the posterior probability. That is a probability of hypothesis given a evidence. So what are the words that you should remember here? What are the terms you should remember here? The probability of hypothesis is the prior probability. The probability of finding the hypothesis given a evidence or data is the posterior probability. So remember these two terms. Now, what do you mean by Bayesian Belief network? The other names, as I told you, is the Bayes network, belief network, decision network, or Bayesian model. So these are all the terminologies. In exam, they may ask you the question based on any of these words. Write down the same explanation. Now, Bayesian network is trying to find out the relation between the events, that events may be dependent or independent of each other, and it is based on the probability distribution of such events. So it is trying to predict some event based on the probability of previous events occurred. Okay, so it is used for the real world applications like diagnostic, time series prediction, or decision making under uncertainty. Means what is the probability of happening some event? That is called as a certainty. And if there is no probability of happening the event, that is called as a uncertainty. And based on the probability value, you can find out the certainty or uncertainty. Now, Bayesian network is represented using DAG. Now, what do you mean by DAG is a directed acyclic graph. Now, acyclic graph means what? It should not contain any cycle, and it is a directed graph. Okay. Now, here you can see we are having a graph. Now, is there cycle in this graph? You can see a loop, but there is no cycle. And each arc should be directed. Whatever is the link between two nodes, that should be directed. And here, what we need is a table of conditional probability. Conditional probability means what? Finding the probability of A given B. That is what the conditional probability. Okay. Now, what is the meaning of this arc that we will try to find out? Now, what is a node in your graph is representing? That is any random variable. That is any event that is occurring. Now, that random variable, if you consider, it may be continuous or discrete. Now, arc is what? Your directed arrow, and that is representing the relationship. Now, listen here, John. When I am putting a arc from A to B, that means what? A is the parent of D. Means what? First, the event A should occur, then only D can occur. And there is no arc between a D and B means what? D and B events are not at all depending on each other, means what, they are the independent event. Now here you can see the one more example that C is independent of A. Why? Because there is no link between the C to A. Okay. And when there is a link, means what? The parent event is influencing the child event. Okay. The parent event is influencing the child. Using this directed acyclic graph, now we will find out the probability distribution. Okay. Now, Bayesian network has mainly two components. One is a casual component and another one is a actual number. Now, how each node in Bayesian network is represented using probability distribution. Now, there is a node X. Okay. Now, its probability I can find out if I know the probability of occurring the parent event of X. Okay, means what is the effect of occurring the parent event on the child event, that I can find out using this formula. Okay, and Bayesian network is whole and sole based on the conditional probability and the joint probability. Okay, now what is the formula for joint probability? Now, it is possible that event X1 can have parent X2 to Xn. Okay, based on the levels. Huh? Now, how I can say? Now, C's parent. Who is the parent of C here? D. C's parent is what? D. Then D's parent is what? A. Means how many level I am considering here? Two levels. Okay, so that is what? More than one parent. Okay, for any node is possible. Now, how I can find out the probability of X1 to Xn using the joint probability distribution? How? The probability of X1 given X2 to Xn is multiplied with the probability of X2 to Xn. So when I'm trying to generalize this formula, I can generalize at the end as the probability of Xn minus 1 is obtained given the probability of Xn multiplied by probability of Xn. So when you are trying to put it in using the summation equation, you can say as I is equal to 1 to n, P of xi is depending on all the parent node of xi. So this is the generalized equation for joint probability. Okay. Now, let us consider a very famous example for Bayesian belief network. Most of the time in exam, the same example will be asked. Okay. Now, there is a burglar alarm installed at home. Which alarm? Burglar alarm. Now, what the name is suggesting? If there is a burglar attack, then alarm should generate sound. Okay. And we are considering that it is a reliable one. Now, there are two neighbors, John and Mary. They may hear this alarm and they will make a call. But John is confused in between the telephone ring and alarm. Means he may call even for a false alarm. Means when a telephone has a ring. Means there is no alarm, but by hearing the telephone ring, he may call. And in the same way, Mary will get confused in between the music and alarm. Means by hearing the music also, Mary may call. Now, based on this, some questions will be generated. Now, this is all the data that I am having. Now, what is the probability that the alarm has sounded? But there is no burglar attack, no earthquake. Now John and Mary has called. Now what is the probability? Means it is a false alarm. Now how we can find out? John and Mary has hear alarm, but there is no burglar and no earthquake. That's why I'm representing it by the negation equation. Now, how I can find out this one by the joint probability equation? Probability of John called when there is an alarm, that is what the 0.90. Probability of Mary called when there is alarm, that is the 0.70. Now, probability of alarm when there is no burglary, that is the 0.001. Now, probability of no burglar means 1 minus 0.001, that is what the 0.999, and 1 minus 002 point is what the 0.998, that is the probability of no earthquake. So, this is the answer for your question. In the same way, one more question. What is the probability that John will call? Now, John may call when there is an alarm or there may not be alarm and telephone ring. Okay. There may be alarm or there may not be alarm if the telephone has rang. Then John may have a false assumption that there is alarm and he may generate a call. Now, how I can find out the probability of A? The probability of alarm is based on all these possibilities. Means on this truth table it is based. Means there is a burglar attack and earthquake. There may be no burglar attack and earthquake. There may be burglar attack and no earthquake. There may not be any burglar attack and earthquake. So, in the same way, John may call when there is a no alarm. So, in that case, no alarm is based on again this truth table. Now, probability of John calling when there is alarm is 0.90. So, that 0.90 I have taken here. Now, this 0.00252 is obtained by this culling bracket. Now, how it is possible? Now, probability of alarm when there is both events true is 0.95. Now, this I should multiply with the probability of BE. Now, probability of BE I can find out by multiplying the probability of B and E because both are independent event. So, like this, for every value, you can use these probabilities and try to find out the answer of this curling bracket. And when I'm subtracting this value from 1, I will get this value. Okay. And that I should multiply with the probability of John with no alarm. Now I will get the final value, this one. Okay. So this is the probability that the John is calling. Now, this I am giving you as an assignment that what is the probability of burglary when John and Mary are calling? Because John and Mary may call by either by hearing the telephone ring or by hearing the music. So, this example you have to solve based on the previous two examples. Okay. So, what is the use of Bayesian network? We can construct one such network which is representing conditional independence. Okay. And using this network, we can find out the joint probability distribution. So this is what the main advantage of Bayesian Beleif network. Thank you.